This is a worksheet on trigonometric identities, worksheet 1. Here, a couple of practice problems are given for you. You have about 100 videos on trigonometric identities. You must have watched them by now. And if you've done so, this should be a very simple sheet for you. If not, I'll request you to go through them which are related to your identities. The first 25 will be related to this sheet on trigonometric identities. Now these simple identities can be solved in 3 steps, most of them. And in case you are taking more than 5 steps to solve these identities, then you are not using the most efficient method. So review your process. When I say solve trigonometric identities, I really mean prove identities, which is to prove that left side is equal to right side. And now you can start from left side and prove it is same as right, or you can start from the right side and prove it is same as left. I'd appreciate if you could copy this sheet on and then solve them one by one. In case there is a difficulty, you can send me your comments and I'll help you resolve those things. Let me go through them one by one so that it helps you to recollect how to solve trigonometric identities and help you do in a very efficient way. Now the first one is sin x equals to tan x over secant x, and similarly we have here cosecant x divided by secant x equals to cotangent x. So this kind of trigonometric identities are basic identities which could be solved by using reciprocal trigonometric identities or quotient trigonometric identities. What I'm trying to say is, if you replace tan x by sin x over cos x, right? Or if basically you need to change them in terms of sin x and cosine x, right? Secant x, for example, is equals to 1 over cos x, and you know cosecant x is equal to 1 over sin x. Let me write here. So if you replace these things, all trigonometric ratios in terms of sine and cosine, you should be able to get these first 4. Okay, cotangent is reciprocal of tangent, so it will be cos over sine. Correct? I need not write all of them, but I'm trying to explain you here. So that will take care of first 4 identities. Now the next set of identities are based on Pythagorean identities, and you know sin square x plus cos square x equals to 1, correct? Now this is a Pythagorean identity. You also remember how to prove it. You can make a right triangle, opposite side, adjacent side and hypotenuse, and say a square plus o square equals to hypotenuse square, and when you divide by hypotenuse square you will get this identity. Similarly, you could prove the other 2 Pythagorean identities, right? One is 1 plus tan square x equals to secant square x. The other one is 1 plus cot square x is equal to cosecant square x, correct? So those can be utilized to solve your identities which are following. Now here you can see for yourself, I can write cos square x as 1 minus sin square x, and when I square root it, I get this one. So it is reorganizing the same thing, correct? So think trigonometric identities like this. It will be very easy for you, correct? Now tan square x, you could split this as 1 plus tan square x equals to secant square x. This may or may not be required. What you can do here is 1 minus sin square x. 1 minus sin square x is what? 1 minus sin square x is cos square x, correct? So you get sin square x divided by cos square x, which is tan square x. So 3 steps, you get them all. Do you see that? So So the idea of giving you this sheet is to understand that these identities are not very difficult. They can be solved in a couple of steps, okay? And especially those which are given on this page. Now here we have difference of product of sum and difference, right? So when there's sum and difference, what do you get? You know this a plus b times a minus b is equal to a squared minus b squared, right? So this will help you to solve the next identity, correct? So these are few basic things which are required, and if identities are complicated, which we will deal with in worksheet 2nd and 3rd, there you have to do all these couple of times. You know, there will be combination of these. So this is a very good base for you. So make a copy of this, try to solve them, and I'm explaining you how to solve them, right? Now, this is the way you have to go about here. So when you do 1 plus sine x times 1 minus sine x, you get 1 square minus sine square x. Now 1 square is 1, 1 minus sine square x is cosine square x. In fact, this Pythagorean identity is one of the most useful of all to prove Pythagorean identities. I mean to prove trigonometric identities. You can write this in different ways, correct? You can write sine square x as 1 minus cos square x, correct? Or cos square x as 1 minus sine square x. So when you multiply these, you get 1 minus sine square x, which is same as cos square x. You get in 3rd step, correct? Now things like this, sin x, cos x, just write tan x as sin x over cos x. If you do that, sin x over cos x will cancel out. Sin x, I mean sin theta in this particular case, sin theta will make it sin square theta. And again you get what? Sin square theta minus 1 instead of 1 minus sin square theta. So you get minus cos square theta, correct? So you prove that one. In this, write sine and tan, secant x and tan x in terms of sine and cos. Secant is 1 over cos and tan is sine over cos. Once you do that, you should be able to get this one also. Similarly, follow these steps, right? These last ones look complicated, but they are not. For example, if I change this tan x as sine over cos, then sine and sine cancel out, cos goes into the numerator, it becomes cos square x. And you know, 1 minus sine square x is cos square x, right? Cos square x is 1 minus sine square x, correct? So that is how it is. So these are not difficult. Here, what should you do? You want sine x at the bottom, right? So what we will do is, we can start on the right side or left side, doesn't matter. If you are starting from left side, you can multiply both numerator and denominator by 1 plus cos x. If you do that, you get 1 plus cos x in the denominator, and on the top, it'll be 1 minus cos square x, which is sine square x. Hence, one of the signs will cancel out and you get your answer. And if you do with the right side, what you can do is, we call this rationalize. We will multiply this by 1 minus cos x. 1 minus cos x. So same thing, right? So 1 plus cos x times 1 minus cos x will give you what? 1 minus cos square x, right? Now this 1 minus cos square x is really sine square x, correct? Right? I'm not solving it but showing. So this is sine square x, and one of the sine x gets cancelled, right? And on the top you do have 1 minus cos x. Do you see that? So this actually, this times this gives you 1 minus cos square x, which is sine square x, right? So that is, I don't have enough room here. Let me go up and do it here now, completing it. So this is sine x times this, right? So this is times sine x. Now 1 minus cos square x is sine square x, right? And on the top you have sine x, what I'm going from, sine x times 1 minus cos x. Is that okay? So one of the sine x cancels out and you get 1 minus cos x divided by sine x. So again, 3-4 steps, right? You get there. So what I'm trying to say here is, all these identities, which may look complicated, are simple to prove. And basic strategies which you're going to use is write them in terms of sine and cosine, and then use sine square x plus cos square x equals to 1. Pythagorean identity, rearrange them and get your result. At times, you may have to use a plus b times a minus b equals to a square minus b square, and get your answers. I hope this sheet is extremely useful for you, and we'll move on to the trigonometric identities worksheet 2. Thank you.